Hi everyone, welcome back to section 6.2, and in this video we're going to establish the theorem of existence of power series solutions, and this is going to allow us to solve differential equations of this form where we have functions of x as coefficients. So we're going to use power series to solve these differential equations. This is about power series, about ordinary points. So what is this theorem exactly saying? So if x naught is an ordinary point of the differential equation, a2 of x y double prime plus a1 of x y prime plus a naught x times y equals 0, we can always find two solutions of the form of a power series centered at x naught. That is, we can find a solution of this form centered at x naught. A power series solution converges at least on some interval divided by, the interval of convergence, and r is the radius of convergence. So essentially, you know, I want to find two power series solutions to a differential equation at the center. So just to reiterate what this is saying, that a solution of the form series C sub n x minus x naught to the n of power series is said to be a solution about an ordinary point x naught. And so to make life a bit easier for us, we always desire to have the center be x equals 0 because we want our power series solutions centered at x equals 0. Because, if we have a power series solution like x minus 0 to the n, right? Well, that's just a sub n x to the n, and that's a lot easier to work with. Okay, so that's what we strive for. Okay, so relaying that back to the theorem. Okay, so if x equals 0 is an ordinary point, because we need it to be an ordinary point, I can find two power series solutions to the differential equation centered at x equals 0. So that's my goal. Okay, and that's what the theorem allows us to do. So let's look at a couple applications of some power series, second order, non-constant coefficient differential equations. So we have the Cauchy-Euler equation, so that looks familiar to what we learned previously. We had the Cauchy-Euler method, but here, we can solve it with power series solutions if we want. We have the Hermite equation. We have the Legendre's equation, Bessel's equation, Airy's equation, which we're going to solve in this material, and Chebyshev's equation. Chebyshev equation is pretty interesting. Um, but yeah, so there's a couple examples of differential equations for physics and engineering, and power series allows us to solve these and play around with them a bit. So just wanted to introduce the theorem and a couple equations. We're going to get going on solving some of these, but that's it for this video. Thank you for watching, and I'll see you in the next one. Take care.